All right, so we talk a lot about planning and designing software tests, right? But how does a test go from just an idea, a blueprint, to something real, something that actually finds bugs? Well, that's exactly what we're going to break down today. So picture this. You've got a perfectly designed test case. It's got the steps, it's got what's supposed to happen, but right now, it's just words on a screen. It's an idea. How do you bring that idea to life? How do you make a computer actually run it? That's the puzzle we're solving. Okay, so our journey from that blueprint to a real working test, it all starts at the starting line. And here, it's all about preparation. And you know what? This whole preparation phase, it actually has a name. It's called test implementation. It's this super critical, but honestly often overlooked step that happens between designing the test and actually hitting run. This is where you set yourself up for success. All right, let's dive into that. For setting the stage, this is all about creating the perfect conditions for our test to do its thing. I love this analogy. Think of a chef doing their mise en place. Before they even think about turning on the heat, they've chopped all the veggies, measured all the spices, got everything prepped and ready to go. Well, that's exactly what test implementation is. You're developing the procedures, creating the data, and getting that test environment just right. And to do this right, you really need a specific toolkit. The pros call it testware. These are the key items you're actually going to build during this implementation phase. So let's open up this toolkit and see what's inside, shall we? First thing in the kit is the test procedure. And honestly, the easiest way to think about this is like a recipe. It's that super detailed step-by-step instruction manual that makes sure you or anyone else can run the test exactly the same way every single time. And, well, you can't follow a recipe without ingredients, right? That's your test data. This is all the specific info, the user accounts, the product IDs in the database that your test is going to use or maybe even change. Okay, now here's where we get smart and efficient. Instead of just running tests one by one, which you could do, you can bundle them into what's called a test suite. This is genius for when the result of one test, say, create a new user, becomes the perfect setup for the very next test, like log in with that new user. And last but not least, probably the most technical piece in our kit, the test harness. Okay, imagine you need to test a car's fuel injector, but you don't have the whole car built yet. A test harness is like that special rig you'd build in the garage just to fire up that one part and see if it works. In software, it's a mini environment you create to run and test a piece of code all by itself. So if we put that all together, this whole implementation stage really boils down to three main jobs. First, you're finalizing those step-by-step procedures and creating all your test data. Second, you group those tests into smart, efficient suites. And third, you build and double-check that your test environment, including any of those special harnesses, is set up and ready to roll. Okay. The stage is set. The toolkit is packed. The actors know their lines. Now, it's showtime. This is the part everybody thinks of when they hear software testing. This is the main event. Test execution. And execution? It's kind of like a 5-step dance. First, you execute the tests, following your procedure to the letter. Second, you log everything, and I mean everything. Then, step 3, the moment of truth. You compare the actual results to what you expected to happen. If they don't match up, that's step 4. You report it as a problem and start digging. And finally, step 5. Once a fix is in, you repeat the test to make sure it actually worked. And this is a perfect example of that moment of comparison. On the left, our plan, our expected result, was user login is successful. Simple enough. But on the right, what actually happened? An error message, invalid password. So right there, the plan and reality just went in two different directions. So here's the million-dollar question. What happens now? You found a discrepancy. Do you just, yell across the office, "Hey, it's broken"? Nah, of course not. There's a formal, structured process for exactly this situation. And this leads us straight into how we handle the unexpected. Because when a test fails, you don't just throw up your hands. You kick off an investigation. And that mismatch, that difference between what you expected and what you got, it has a formal name, an incident. Now, the key phrase there is requires investigation. See, it's not a confirmed bug just yet. Think of it more like a clue, a lead that a detective needs to follow up on. And what does every good detective need? Evidence. You can't solve the case without it. To figure out what's going on, you absolutely have to have a crystal clear, detailed record of exactly what happened during that test. And that record, that's your test log. Seriously, think of it as the detective's notebook. It is a chronological, time-stamped record of every single detail: which version of the software, which test case, what data was used, and what happened at every step. This log, this is what makes finding the root cause of an incident even possible. Phew. Okay, we've covered a ton of ground, from blueprints to bug reports, so let's pull it all together on a final scorecard: implementation versus execution. You know, it's actually pretty simple when you lay it out like this. Test implementation is all about one thing: preparation. That's those 3 key tasks we talked about: making procedures, suites, and environments. Then you have test execution, which is all about action. And that's our 5-step dance: run, log, compare, report, and repeat. Prep, then act. When you get right down to it, this whole structured process, all the prep work, all the careful execution, it all exists for one simple reason: to give us a reliable, evidence-based way to report incidents whenever reality doesn't match our plan. That discipline, that's how we find and ultimately fix bugs. And that leaves us with one last kind of provocative question to chew on. We've just walked through how incredibly structured and methodical professional testing really is. So, if that's the case, why do so many bugs still make it into the software we use every single day? Something to think about. Thanks for joining me on this explainer.